Hi everybody, this video will cover a few word problems for similar triangles, and it's really just meant as an additional example to my similar polygon video. So we'll start here. Let's find the distance x across the lake. The figure is not to scale because I made it myself. So what you can see here is I have a large triangle where x kind of goes across this piece of the lake, and we know this bottom distance is 115 feet. It is lined up with another triangle, and you can see this forms one line that goes through the hypotenuse of each of them, and this is 24 feet, and this is 18 feet. What we are going to do here is use similar triangles. Now, how do we know they're similar triangles? Well, we know they both have a right angle, and because this lines up, we know that these are vertical angles. So what do I know? I know that this angle is the same as this angle, and then the right angle is the same as the other right angle, which means that these last two angles have to be the same as well. So I know that corresponding angles are equal, which means that corresponding sides will have a constant ratio. So what we have to do is line up what corresponds to what, and what do we know? So what I'm going to look at is this 24 compares to the 115. I'm going to put the big one first. I'm going to say 115 compares to 24, so the big to the big, and I drop the units because they're the same and they would cancel. And that would be equal to, well, from the big triangle, I have x. From the little triangle, I have 18. Again, they should both be in feet. So what I want to do here is cross multiply. I'll have 115 times 18 will be equal to 24 times x. 115 times 18 is 2070. That's 24x. So my last step is to divide by 24. This says that x would be equal to 86.25 feet. Again, I just made up some numbers. 86.25 might not be too big for a lake, but we're going to go with it. So let's try another one. A diver is 12 feet from a boat and can see 2.5 feet down in the water. 42.5 feet down from the diver is a shark that is swimming in line with the diver. We want to find the distance between the shark and the diver. Again, the figures are not to scale. Part of what you see here is this 42.5 feet, which is the depth of the shark, got broken into the 2.5 feet down that the diver can actually see, and the other 40 feet down where the shark is hanging out. Again, we have this kind of line of sight where we're going to pretend the shark can see the diver can't see the shark, and we want to know how far away is this shark from the boat, which is where the diver is headed. So once again, we want to form some similar triangles. So first, I know that this is going to be the same as this because we have vertical angles. Because of the way the triangles are laid out, we can also see we have right angles, which again forces the third angles to be the same. So we have three sets of corresponding angles, which means we should have corresponding sides as well. So what we want to do, again, I'm going to go with the big distance first. So 40 over 2.5 should be equal to x over 12. We will cross multiply. 40 times 12 is going to be 2.5 times x. 40 times 12 is 480. I still have 2.5x, so let's divide by 2.5, divide by 2.5. This says that x is equal to 192 feet. Again, if you're a shark expert and you know anything about how far they can see, I wasn't trying to be accurate on that part. I was just trying to give us a scenario that would be fun to look at similar triangles. I hope these extra two examples make your homework easier. Good luck.